This lesson deals with supplemental problem 210. You can find this problem in the ECE201 ebook in the Chapter 2 Supplemental Problems on page 9. Suppose that we have a circuit in a box and we cut a hole in that box and we can see pieces of the circuit and that we're able to measure some of the things in that particular piece. What I want to do is then use Kirchhoff's voltage law and current law and Ohm's law to solve for remaining voltages and currents. In this particular case, the current I and the voltage between these 2 points A and B, this open circuit. I've redrawn the circuit at the bottom of the page here. What I'm doing with this particular technique is I'm going to label each of the steps that I'm doing to try to solve for those two variables I and V sub AB. I want to write as many equations as I can right on the schematic itself. This will help as we look at bigger and bigger schematics. So in the problem above, I was given that this was 6 volts. Well, since I know the resistance, I can use Ohm's law to find the current of 2 amps. Since I have 3 amps entering here, and I have 2 amps leaving here, then I must have 1 amp left over here. And that was my second step. If I have 1 amp here, then I've got a drop from here to here of 1 amp times 2 ohms or 2 volts. Now on the other side over here, I've got this 2 amps here. I know that this current is 1 amp and this current is 1 amp. So 1 amp is entering, 2 amps is entering, 1 is leaving, so I have 2 left over. So that's my fourth step. If the current is 2 amps and I have 6 ohms, then I have by Ohm's law, 6 times 2 are 12 volts. I also know that the voltage across this 4 ohm resistor is 12 volts, so I could use Ohm's law to find the current. And that would be 12 volts divided by 4 ohms or 3 amps. And that's my sixth step. So 2 entering, but 3 leaving, and this is also leaving, so it would have to be equal to -1. And that's the work right down over here. Now let's go around a loop here. Here's my V sub AB. I can go back this way, and I've got all the voltages figured out except V sub AB. I could go around the loop clockwise. I can go around the loop counterclockwise. Let me go around counterclockwise just to be different. So here I've got a rise in voltage of V sub AB. I have a rise in voltage of 2. I have a drop of 6, a drop of 12, and a rise of 12. And that's shown on the bottom of the page. So here's my rise in voltage of V sub AB, 2, and then I had 12 on this other term, and I had 2 drops here of 6 and 12. The 12s cancel on both sides of the equation, and I can bring the 2 over here as a -2, and so V sub AB is equal to 4 volts. This is supplemental problem 210.